Imagine falling towards something so powerful that the universe itself seems to break down around you. There's no solid surface, no explosion, no giant cosmic monster waiting inside. Just gravity, a force so extreme that once you cross a certain invisible boundary, there may be no way back. And here's the terrifying part. Black holes aren't rare accidents in the universe. There are probably millions, perhaps billions of them scattered throughout galaxies. So, what exactly happens when something falls into one? And could a black hole ever threaten Earth? Today, we're going to uncover the terrifying truth about black holes and some of the strangest things we know about these objects. First, forget the idea that a black hole is simply a giant hole in space. It isn't. A black hole is an object where matter has been compressed into an incredibly small region, creating an enormous concentration of mass. Its gravity becomes so powerful that beyond a certain point, even light cannot escape. That boundary is called the event horizon. Think of it as a cosmic point of no return. If you were somehow approaching a black hole, nothing special would suddenly appear as you crossed the event horizon. But once you crossed it, every possible future path would lead deeper toward the black hole. Even light traveling at nearly 300,000 kilometers per second couldn't escape. And that's where things become truly disturbing. According to Einstein's theory of relativity, gravity doesn't just affect objects, it affects time itself. The stronger the gravitational field, the slower time passes relative to someone farther away. Imagine you're approaching a black hole while your friend watches you from a safe distance. From your perspective, your watch keeps ticking normally. But from your friend's perspective, something strange happens. As you approach the event horizon, your movements appear to slow down more and more. Your signals become increasingly delayed and stretch toward longer wavelengths. Eventually, from your friend's viewpoint, you would appear to fade away near the horizon. But from your own perspective, you wouldn't necessarily notice your time slowing down. You would continue falling. That difference between what you experience and what a distant observer sees is one of the strangest predictions of relativity. Now let's imagine the worst case scenario. You're falling toward a black hole. At first, everything might look relatively normal, but as you get closer, the difference in gravity between different parts of your body becomes enormous. Your feet could experience significantly stronger gravity than your head. That difference creates extreme tidal forces, and eventually, those forces could stretch your body dramatically. Scientists have given this phenomenon a rather unsettling nickname: spaghettification. Yes, you could literally be stretched into a long, thin shape by the black hole's tidal forces. But here's an important detail. Not every black hole would destroy you immediately at the event horizon. For a relatively small black hole, the tidal forces near the horizon could be catastrophic. But for a supermassive black hole, the event horizon can be enormous. You could theoretically cross the horizon without immediately feeling anything unusual. The real danger would come later, as you continued toward the center. And that brings us to one of the biggest mysteries in physics. At the center of a classical black hole is what physicists call a singularity. Our current equations suggest that matter could be compressed to an unimaginably extreme state where density and space-time curvature become infinite. But there's a problem. When our equations produce infinities, it often means our theory has reached its limit. General relativity works incredibly well. Quantum mechanics works incredibly well. But inside the deepest regions of a black hole, we need a theory that can describe gravity and quantum physics together. And we don't yet have a complete theory of quantum gravity. So when someone asks, what is actually at the center of a black hole? The honest answer is, we don't know. And that uncertainty may be one of the most terrifying things about black holes. Here's a myth that needs to disappear. Black holes aren't cosmic vacuum cleaners. If our sun were somehow replaced by a black hole with exactly the same mass, Earth would not suddenly get sucked into it. The gravitational pull at Earth's orbit would be essentially the same. Earth would continue orbiting. The problem? We would lose sunlight. And without sunlight, life on Earth would face catastrophic consequences. So black holes don't magically pull objects toward them from enormous distances. You have to get sufficiently close for their extreme gravitational effects to become dangerous. In fact, from far enough away, a black hole's gravity behaves just like the gravity of any other object with the same mass. Now let's go bigger, much bigger. At the centers of many galaxies are supermassive black holes. These monsters can contain millions or even billions of times the mass of our sun. And our own galaxy isn't necessarily an exception. At the center of the Milky Way sits Sagittarius, a star, a supermassive black hole with a mass roughly 4 million times that of the sun. And here's the strange thing. It's about 26,000 light years away from Earth. So despite its enormous mass, it isn't currently a threat to our planet. But imagine getting close to one. A supermassive black hole can be surrounded by a disk of gas and dust spinning at incredible speeds. The material can become incredibly hot. It can release enormous amounts of radiation. And in some galaxies, the region around the black hole can become brighter than the galaxy itself. These objects aren't just dark. Their surroundings can be some of the brightest places in the universe. Now you're probably wondering, could one come wandering into our solar system? Technically, a black hole could interact gravitationally with stars and planets. But there is no known black hole currently heading toward Earth that poses such a threat. And fortunately, space is enormous. The chances of a dangerous black hole simply passing through our solar system are extremely low. But there's another danger that's much more realistic. A black hole doesn't need to physically touch Earth to affect us. If a massive object passed close enough, its gravity could disturb planetary orbits. And if Earth were somehow placed on a dangerous trajectory around a black hole, the consequences could be catastrophic. But don't panic. There is currently no evidence that this is happening. Here's something even more incredible. Black holes can orbit each other, and eventually they can merge. When two black holes collide, the event releases an enormous amount of energy, not primarily as visible light, but as gravitational waves. These are ripples traveling through space-time itself. In 2015, scientists detected gravitational waves from a black hole merger for the first time. Humanity had essentially detected two black holes colliding across the universe. Think about that for a moment. The event happened billions of years ago. The waves traveled through space for an enormous amount of time, and eventually, they reached Earth. Our detectors measured an incredibly tiny distortion in space-time. For the first time, we weren't just observing the universe with light. We were listening to it through gravity. And now, we reach one of the biggest mysteries in modern physics. What happens to information that falls into a black hole? According to classical physics, once something crosses the event horizon, we can't retrieve it. But quantum mechanics tells us that information shouldn't simply disappear. This creates a deep contradiction, known as the black hole information paradox. And physicists have been trying to understand it for decades. There are ideas involving Hawking radiation, quantum entanglement, holography, and the structure of space-time itself. But there is still no universally accepted complete answer. So black holes aren't just objects we haven't explored. They may be showing us that our understanding of reality itself is incomplete. 10. And then there's Hawking radiation. Here's something that sounds impossible. Black holes may not actually be completely black. According to Stephen Hawking's theoretical prediction, black holes can emit extremely faint radiation due to quantum effects near the event horizon. This means black holes can slowly lose energy, and eventually, over unimaginably long periods of time, they could evaporate. For the black holes we know about, this process would take an almost incomprehensibly long time, far longer than the current age of the universe. But if black holes can eventually disappear, then the question becomes, what happens to everything that ever fell into them? And we're back to the information paradox. Black holes are terrifying. But perhaps the most frightening thing about them isn't their gravity. It's what they reveal about the universe. They show us that space and time aren't as simple as they appear. They challenge our understanding of gravity. They force us to confront the limits of physics. And they hide regions of the universe from which no information can escape. We can observe their effects. We can detect their gravitational waves. We can watch stars orbit them. We can even image the shadow of a black hole. But we still don't truly know what happens beyond the event horizon. And perhaps that's the greatest mystery of all. Because somewhere out there, millions or billions of black holes may be silently drifting through the universe. Invisible.
Just
ancient,
gravity.
Powerful.
A force so extreme that once you
completely
cross a
indifferent to
certain
us.
invisible boundary,
So the next
there
time
may
you
be
look
no
up at
way
the night
back.
sky, remember,
Black holes aren't
the
rare
darkest
accidents.
objects in the universe
There are probably
may not be the
millions,
things we can
perhaps
see,
billions of them
but the
scattered
things
throughout
from
galaxies.
which nothing can ever return. And that is the terrifying truth about black holes.